This is Mr. Beck Does Your Homework. This is AP Physics, Homework 12.2, question number 7. I do say this is not a small angle, so we're not going to be able to use x equals m lambda L over d. So we have a much bigger angle here than a small angle. So it says plane sound waves of wavelength 0.13 meters are incident on two narrow slits in a box with non-reflecting walls as shown in the figure. At a perpendicular distance of 7 meters from the center of the slits, a first-order maximum occurs at a point 5 meters from the central maximum. What's the distance between the two slits? So what we know is the wavelength is 0.13 meters. So let me write down wavelength equals 0.13 meters. I know that the distance is 7 meters, so that's L equals 7 meters. It says the first order maximum, so if I was doing m lambda L over d, I would know that m equals 1. That's going to be important. And it says it's 5 meters from the central maximum, so that is x equals 5 meters. Now I can't use x equals m lambda L over d because it's not a small angle, but what I can use is d times the sine of theta equals m times lambda. So I do have m and lambda, and I'm looking for d, but I would need sine theta in order to solve for that. So let me rewrite this and say that d equals m lambda over sine theta. Now I don't have theta yet, but I do know that this is 7 meters and this is 5 meters, so if I'm clever I can figure out that the tangent of theta is equal to the opposite, which is 5, divided by the adjacent, which is 7. So that's the tangent of theta is 5 over 7. So for me, I can calculate this with an inverse tangent to get theta, plug theta in here, and now I have m times lambda divided by sine theta, and that will give me d. That'll give me d in meters, and it's asking for d in meters. So by combining this and this is how you work a not small angle answer out of a double slit experiment.